Operation Research. Unit 1. Introduction to Operation Research. My name is Patricia Valdivia and my team is Carlos Aguilar, Raquel Perez and Juliana Garcia, which will present this topic. 1.1 Definition, development, and types of Operation Research Model Lesson. 1.2 Phases of study of the investigation of operation. 1.3 Main application of operation research. 1.4 Methodology for modeling. 1.5 Formulation of common linear problems. 1.6 Concept of the graphic method and its application. 1.1 Early work in operation research was carried out by individuals such as Charles Babbage. His research into the cost of transportation and sorting of mail led to England's universal penny post in 1840, and studies into the dynamical behavior of railway vehicles in defense of the GWRS brought operation research to bear on problems on cycles in the 1920 and would later opted to extend this to the social science. Nowadays, modern operation research originated at the Botsey Research Station in UK in 1937 to analyze and improve the working of the UK's early warning radar system. Is the attack of modern science and complex problems arising in the direction management of large systems of men, machines, materials, and money in industry, business, government, and defense. Its distinctive approach is to develop a same model of the system, incorporating measurement of factors such as change and risk, with which to predict and compare the outcomes of alternative decision strategies or controls. The pursuit is to help management determine in policy and action scientific. Definition, development, and types of operation research modelation. Point first is a systematic and analytic approach to decision making and problem solving. Point second is a branch of applied mathematics that use techniques and statistics to arrive at optimal solutions to solve complex problems. Point third, determining the system behavior. Point 4. Analyze the system behavior by developing appropriate models that measure subdisciplines in modern operation research, as identified by the journal Operation Research, Computing and Information Technology, Financial Energy, Manufacturing, Service Science, Supply Chain Management, Policy Modeling and Public Sector Work, Revenue Management, Simulation, Transportation. Phases of the study. Definition of the problem. The objective is to identify three main elements. 1. Description of the decision alternatives. 2. Determination of the objective of the study. And 3. Specification of the limitations under which the modeling system works. Construction of the model. 1.3 Main application of operation research. 1. In the combinatorial domain, enumeration is often impossible. 2. When in the phenomena study random interference. 3. When there are situations of concurrence. 4. When we observe that scientific methods are cumbersome for our dataset.
Hi, my name is Raquel, and the next topic is methodology for modeling. Identify the elements of the problem. Express the objective related to the problem, indicating the units in which it will be measured. Define the decision variables. Formulate the function of the objective and function of the constraints of the mathematical model. Main types of restriction: capacity restriction, ticket restriction, market restriction, balance restriction. And the next topic, Carlos.
Formulation of common linear problems. Linear programming. Definition. Linear programming is a class of mathematical programming models for the efficient allocation of limited resources in known activities in order to meet the desired goals, maximize benefits, or minimizing cost. The main elements of a linear programming model are the variables or unknowns, the objective function, the restrictions. Formulating LP problems. One of the most common LP applications is the product mix problem. Two or more products are produced using limited resources such as personnel, machines, and raw materials. The profit that the firm seeks to maximize is based on the profit contribution per unit of each product. The company would like to determine how many units of each product it should produce so as to maximize overall profit given its limited resources. Flair Furniture Company. The Flair Furniture Company produces inexpensive tables and chairs. Processes are similar in that both require a certain amount of hours or carpentry work and in the painting and varnishing department. Each table takes 4 hours of carpentry and 2 hours of painting and varnishing. Each chair requires 3 of carpentry and 1 hour of painting and varnishing. There are 240 hours of carpentry time available and 100 hours of painting and varnishing. Each table yields a profit of $70 and each chair a profit of $50. Flair Furniture Company. The company wants to determine the best combination of tables and chairs to reach the maximum profit. Flair Furniture Company. The objective is to maximize profit. The constraints are: 1. The hours of carpentry time used cannot exceed 240 hours per week. The hours of painting and varnishing time used cannot exceed 100 hours per week. The decision variables representing the actual decisions we will make are: T. Number of tables to produce per week. C. Number of chairs to be produced per week. We create the LP objective function in terms of T and C. Maximize profit $70 T plus $50 C. Develop mathematical relationship for the two constraints. For carpentry, total time used is 4 hours per table number times number of tables produced plus 3 hours per chair times the number of chairs produced. We know that carpentry time used is less or equal carpentry time available. 4T plus 3C equals 240 hours of carpentry time. Similarly, painting and varnishing time used, painting and varnishing time available. It equals or less. 2T plus 1C is less equal to 100 hours of painting and varnishing time. This means that each table produced requires 2 hours of painting and varnishing time. Both of these constraints restrict production capacity and affect total profit. The values for T and C must be non-negative. T should be greater or equal to 0. Number of tables produced is greater than or equal to 0. C greater or equal to 0. Number of chairs produced is greater than or equal to 0. The complete problem stated mathematically. Maximized profit equals $70 times T plus $50 times C. Subject to 4 times T plus 3 times C, it's less or equal to 240 carpentry constraints. This is the formula for carpentry constraints. 2 times T plus 1 times C, it's less or equal to 100 painting and varnishing constraints.
Concepts of the graphic method and its application. The graphic method of problem solving of linear programming only applies to problems weighted through decisions, variables, or whatever. It adequately illustrates the concepts that will allow us to understand the nature of the place problem and to understand the algebraic solutions methods. Graphical solution to an LP problem. The easiest way to solve all small LP problems is with the graphical solutions approach. The graphical method only works when there are just two decisions variables. When there are more than two variables, a more complex approach is needed, as it is not possible to plot the solutions on a two-dimensional graph. The graphical method provides valuable insight into other approach work. Examples of graphical representation of a constraint. 40 more 3C less than or equal to 240 hours available. For constraint 4 for 30 and 3 for 20 equal to 180 hours output. For painting, 2T more 1C less than or equal to 100 hours available. For constraint, true for 30 more 1 for 20 equal to 80 hours available. For the points, 30 and 20 is correct. Thank you for your attention.